All right, AP Calculus students. So I'm going to go ahead and do the Unit 6 multiple choice practice. I feel like I've been slacking off with these, so I'm going to see if I can get a couple of these videos done before school today, and then that way you guys can get a head start on this. Yeah, I'll probably assign maybe a few of these over the weekend so that you can at least get through Unit 7, and then the last week before your last mock exam, I'll make sure to have the rest of them uploaded for Units 8 and the Unit C, which is Unit Calculator questions. So let's just go ahead and look at this. So for 101, let R of t be a differentiable function that represents the rate at which people leave a restaurant in people per hour after t hours since opening. What is the approximation of the total number of people who have left the restaurant from t equals 0 to t equals 10 if a left Riemann sum is used with 4 subintervals as indicated by the table? So I don't know about you guys, but I always like to say if I'm dealing with 4 subintervals, and I'm going to see what I can do to kind of just kind of sketch like 4 little rectangles right there. And, you know, I'm just kind of picturing those rectangles, and what they want us to do is a left Riemann sum. So I'm really looking at just the left values of those rectangles. So I'm only going to be focused on pretty much these values when I'm doing that. So now I'm going to look at like each specific rectangle. Let me pick a different color. Let me do this blue. All right, I'm going to look at each little rectangle. I'm going to say, okay, well, the width of this rectangle, it's length times width. That's area of a rectangle. Hope we all knew that. So the width is 2, and then the height is going to be whatever our output function is. So it's going to be 2 times 2. And then plus this width is also 2, so 2 times, and then the height is 4. Plus this width is 3, from 4 to 7. And then the height is just going to be 1. And then plus, and then this width is going to be 3 again. And then the height is going to be that left side, which is 8. All right, so, you know, if this were the free response, I'd say stop there. But this is not an answer choice. So let's go ahead and simplify this. We have 4 plus 8 plus 3 plus 24. This is 12. This is 27. These two are 39. So D. Okay. Let's see. Let f be a differentiable function. Selected values of f of x are given in the table above. What is the estimate from the integral? So pretty much they're saying the same thing where, like, you know, you want to know the area under a curve. If you want to have an estimate using Riemann sums, most likely, of this integral, I'm going to use a Riemann sum with, just 2. 2 equals midpoint, sorry. I totally skipped over that word. So 2 equal subintervals with a midpoint Riemann sum as indicated by the table above. So if I think about this, I'm going to create 2 rectangles out of this. Again, I always start with my number of how many subintervals I'm doing. So if I'm doing 2 rectangles right there, but they want me to use the midpoint Riemann sum, I'm going to look at the middle of those rectangles. And those are going to be like the heights that I'm going to use right there. So when I set this up, let me see, the width of that rectangle is from 1 to 9, which is just going to be 8. And then the height of that rectangle is going to be that output value of 3. Plus the width of this rectangle from, I can't even see what that says, is that 9? Yeah. So from 9 to 17 is 8 again. And then times that height of 2. So we have 24 plus 16, which is 40. All right, going back and forth between blue and red. All right, let f be a differentiable function, blah, 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 blah. If a trapezoidal sum with 3 subintervals, so from 4 to 11, as indicated by the table above. So some of you have like better shortcuts than I do of like putting the 1/2 in front and then only looking at the sum. Me personally, it helps me to write the whole equation for every little thing. It takes me a few more seconds than the other people would, so I'm just going to go ahead and do it. So they said 3 subintervals, so I'm going to draw 3 rectangles, and it always works out perfectly. I mean, so far, I'm not going to say always, but most of the time it works out perfectly in the table. Okay, so then I have 3 subintervals, so I'm going to look at this trapezoid right there. So it's going to be 1/2 times base 1 plus base 2 times the height, and you know, you have to remember, these like trapezoids are going to look, you know, something like this. So this is like base 1, base 2, and then the height is like pretty much what our, like before what our width of a rectangle would be, but our height, in this case, it's a lying down trapezoid. So the height or the width of this one is 3. So and then plus 1/2 times base 1 plus base 2, 1 plus 4. I get the feeling that the mistake that's going to happen a lot here is you're going to accidentally use those values. No, make sure you use your function output. Anyway, so 1 plus 4 times the height, which is really the width between those two, is 1, plus 1/2 times base 1 plus base 2, 4 plus 3. And then the width of that is going to be 3 again. So hopefully I did all that right. And let's work this out. So here we have 1/2 times, let's see, why am I struggling right now? It's 3 times 3 is 9, plus 1/2 times 5, plus 1/2 times, this is 7, and 3 times 21. So let's see, 9 halves is 4.5, 5 halves is, oh my god, why am I struggling? 2.5. It's too early for this. 21 halves is 10.5. This is 7. 7 plus that is 17.5. Got it. Okay. So I think that's good. So that was a pretty good refresher of Riemann sums. So now if I look at 104, let's see. Let f be a twice differentiable function that is increasing and concave down on its entire domain. If a finite number of rectangles are used on the interval from a to b, which of these estimates is an under approximation of the true value of b to a, or a to b? Interesting. So if I have like a function, okay, and it says that from a to b, again, I'm so sorry, this is so early for me. From a to b, it says it's a twice differentiable that is increasing and concave down. So it's, how is that possible? So I guess it's increasing and concave down, right? So I'm just gonna draw first. Let me try like a left Riemann sum. Let's just do like, I don't know, I'll just do 2 subintervals. So I'm gonna do a left Riemann sum. So it's really from here to there, and then from here to there, right? So the left Riemann sum is definitely an under approximation. So that's true, which means that the right one is not. So that pretty much eliminates B and D. And I guess just to prove it to you, just to prove it to you, the right Riemann sum, the right Riemann sum, we would start with B and go up here and then go this way and then blah, blah, blah. So that was an overestimation. But now if I did a trapezoidal rule, so that'll be from here to there, and it does look like my trapezoid is going to be slightly below. This trapezoid is going to be slightly below, so that's the trapezoid is also an underestimation. So I'm going to go with C. Yeah, for that one, I had to pretty much draw the picture. That's what helped me the most. All right, so number 105, the limit. Oh God, yeah, this is the one that Miriam sent me a message about. I'll be honest, I did not teach this to you. I don't know how we can do this problem. I don't remember what the formula was for this. It had something to do with like, it was like the sum I think it was like, I'm going to post a video about this so that you guys sort of know if you're curious. I didn't feel like it was worth teaching this. This shows up like once every 4 years on like an AP exam. But I know it's like from 1 to n of b minus a over n, and then times the function of a plus b minus a over n times k, I think. And so I know that this would be like my lower bound, right? I'm trying to think. That would be my that would be my lower bound of the integral. So I know it's not a or c. And then b minus a has to equal 3. So then if this is 2, then that would have to be 5. So that means it's one of those two, from 2 to 5. And I think the fact that that we're dealing with the function squared, it's leading me to believe it's b. I'm not 100% sure. I'm gonna see if I can find like a good video, maybe from like Khan Academy, or like I know Algebros has some good videos I'll see if I can find a video that goes over the summation notation for those of you who are really interested. Because you'll never know. It could be one multiple choice problem on the AP exam, and maybe that multiple choice problem will make the difference. You'll never know. I think you guys understand that every point matters. So for 106, it says let f be a differentiable function if f of x equals the integral from 3 to x of cosine of t minus 3 dt, then f prime. So remember, if I want to take the derivative of like the original function, and it's an integral form, the derivative of an integral pretty much kind of negate, they're inverses of each other. But what you're going to do is you're going to plug in the x into this. So it'll be cosine of x minus 3, and then all of this times the derivative of that upper bound, so times 1. You be careful. I'm doing that just because what if it isn't just going to be 1? Next time it might be x. Next time it might be 3x squared or something like that. You don't know if that upper bound is some other algebraic expression like more complicated than x, then you have to multiply by that derivative. But anyways, that's not the case. So it's just going to be cosine of x minus 3, which is b. All right, so let's see. I don't know how long this video is. I always try to make these videos short. Oh, look. See, this is an example where it's not just going to be x. So with this one, if I want to take the derivative of an integral, it's going to negate each other. So you're going to plug this inside of your function here, right? So then it'll be 2x cubed, and then times, so f of x is equal to 2x cubed, and then times the derivative of that upper bound, so times 2, right? So then this is going to be, if I plugged in 1 into this, so it'll be 2 cubed times 2, which is 8 times 2, which is 16. So that's the answer for that. See, I think most of you would forget to include that 2, so you will forget this 2, so then you'll just go with 8 as your answer, and that is wrong. So be careful with that. Okay, I'm glad they had an example like that. So let f be a differentiable function defined by f of x is equal to the integral from x to on what interval is the graph increasing? Okay. So if f of x is increasing, I'm looking at the first derivative. So if I'm the first derivative of f, I just spat all over my iPad. God, no, I'm trying to wipe the saliva. Oh my god. Anyways, so I need to look at the first derivative of f. So f prime of x is the derivative of all of this. And the derivative is just going to be for a fundamental theorem of calculus. So that's going to be x squared, right, times 1 for good practice. And then I got to see where is this increasing. Well, there's not really an interval to plug into, but, I mean, it's like no matter what x value I plug into that, isn't anything squared always just going to be like positive? So that's all of them. Yeah. The graph is always increasing. Yeah, okay. No matter what I do, it's always going to be positive. So anyways, let's see. Let G a twice. So let G be a twice differentiable function and be defined as g of x equals the integral from 0 to x of that. What is the x coordinate of the point of inflection? Okay, so now I'm going to look at this. So I'm going to say g prime of x, because the point of inflection we usually have to observe the second derivative. So g prime of x is equal to 2x minus 4x squared, because I'm plugging this into those. And then you know what? For good practice, I'll multiply it by 1, because the derivative of the upper bound. And then this will be g double prime of x is equal to 2 minus 8x. So to find a point of inflection, I'm going to set this equal to 0. And then that's pretty much x is equal to, if I add 8 divided by 2, add 8 divided by 8, it'll be 1/4. So there you go. That was easy. And then for number 110, if the integral from 5 to 1 of f of x is equal to 2, and the integral from 5 to 8 of f of x is equal to 3, then what is the value of all of that? Okay, so they always do this. They always like switch up the bounds on me. I'm going to be organized here. So I'm ultimately looking for 1 to 8, because that's like from the lowest possible bound to the highest possible bound. So I'm going to say the integral from 1 to 8 of f of... What? Oh, now I have an f of x plus 2. Here, hold on. for the integral from 1 to 8 of f of x, that's going to be equal to, I'm going to ignore this for now. That's going to be equal to the integral from 1 to 5 of f of x, plus, I know I'm forgetting my dx's, but it's multiple choice, it doesn't matter. Plus, it actually doesn't matter if you, on the free response, they don't take off points for that, I just found out. But anyways, the integral from 5 to 8 of f of x, okay? So from 1 to 5 and then from 5 to 8, those two combined give me the whole thing from 1 to 8. So let's see. I know from, and this is where they're going to trick you. From 1 to 5, you have, from lower bound 1 to upper bound 5, you have, lower bound 5 to upper bound 1. So again, if I switch those two bounds, then that's going to change that to a negative. So it's actually, this is actually equal to negative 2. And then 5 to 8 is plus 3, so that's negative 1. Okay, good. So I figured out that this is negative 1. And so, let me kind of bring that back to life. So now this, I can go ahead and use more integration techniques. So I can break this apart as two integrals from 1 to 8, right? So I just established that this right here is negative 1. And then with this, I can actually solve that integral. Let me do that here on the side. So the integral from 1 to 8 of 2 dx, the integral of 2 is just 2x from bounds 1 to 8. And so that's equal to, if I plug in my upper bound, that'll be 16. If I plug in my lower bound, minus 2, so that's 14. Oh yeah, okay. So what am I doing wrong here? Negative 1 plus 14 is not on there. 13. What did I do? Oh my god. Negative 2 plus 3 is positive 1. Positive 1. Good thing 13 wasn't an answer choice. I would have chosen it. So positive 1 and then 14. 1 plus 14 is 15. Oh my god, that's embarrassing. Okay, it's too early. I'm going to blame it on that. Okay, I'm going to let it go. Good luck with this video. Have fun. As always, I love you guys. Bye.